Hello students, welcome to class 1 of TYBSc Applied Component. For 5th semester, we shall be starting with Chemistry of Dyestuffs. In that, Introduction to Dyestuff Industry. So, let's get started. Students, we know that the nature has abundance of colors. The leaves of plants have various shades of green. The flowers have variety of hues of red, yellow, blue, violet, etc. The birds and butterflies have attractive colors. The rainbow consists of Vibgyor colors. Even in prehistoric times, man has used coloring matter extracted from plants and organisms in cave paintings. Thus, colors play a dominant role in the life of man. Now, let us discuss what is a color. Well, color is what the eyes see when light is reflected off an object. Color has three properties. First is hue. Hue is the name of a color, such as red, blue, or yellow. Second is value. Value is the lightness or darkness of a hue. The value of a hue can be changed by adding black or white. And the third one is intensity. It is the brightness or dullness of a hue. Pure hues are high intensity color. Dull hues are low intensity colors. We know that there are three primary colors, that is red, blue and yellow, and there are three secondary colors, that is green, orange and violet. There are complementary colors, intermediate colors, warm colors and cool colors. Well students, the study of dyes has something to do with colors. So now let us see what is the meaning of dye. A dye or a dyestuff is usually a colored organic substance. It may be a compound or mixture, which when applied to the substrate, imparts color to that substrate. Now, commonly, the substrate is the textile material. In addition to that, there are other substrates such as paper, leather, plastic, waxes, and cosmetics. The non-toxic dyes are used in drugs and are used to color foodstuffs, and the light-sensitive dyes are used in photography. So remember students, a dye is a colored substance, but not all colored substance can act as a dye. For example, azobenzene. Azobenzene, it's a colored one. Then too, it is not a dye because it does not get attached to substrate. On the other hand, Congo red can be retained by cotton. Therefore, it is considered as a dye. Now, let us discuss the requirements of a good dye. First is color, which includes chromophores and oxochromes. Second is substantivity. Third is solubility. Fourth is linearity and coplanarity. And fifth is economic viability. So let us discuss in detail. So the first point is color, which includes chromophores and oxochromes. So remember students, the dye molecule must have one or more chromophores such as carbon-carbon double bond, carbonyl group, nitro group, azo group, etc. and also sufficient conjugation so as to have a color. The presence of oxochromes like hydroxide OH, amino NH2 group, SH mercapto group, Cl chloro group, SO3H sulfonilic acid groups, etc. helps to intensify this color. Hence, the requirement for a dye is conjugation between chromophore and oxochrome. Second is substantivity, that is affinity. Well, it is the affinity between the dye molecule and the substrate, usually textile fibers. The most important requirement of a dye is that it should have a strong affinity to the substrate so that it is retained by the substrate to give it a permanent color. However, the force holding the dye on the substrate may be physical or even chemical, and the presence of more oxochromes increases the affinity between the dye and the substrate. Third is solubility. The dye is applied to the fiber in the form of its solution. Hence, the solubility in a suitable medium like aqueous or organic becomes an important factor. The presence of solubilizing groups like SO3H, phenolic OH group, etc. increases the solubility of the dye. Fourth is linearity and coplanarity. Well, the structure and shape of a dye molecule affects the affinity between the dye and fiber. The fibers are linear, and if the dye molecule has a linear structure, then it can be oriented along the fiber and hence can have stronger attachment to the fiber. If the dye molecule has a coplanar structure, then there can be extensive resonance, resulting in increase in intensity of color. Moreover, if dye is coplanar, it can be oriented properly with the substrate, thus increasing the van der Waals forces between them. Thus, linearity and coplanarity of dye molecule plays an important role in the dye fiber affinity. Fifth is economic viability. Well, dyes are prepared in huge quantities to be applied to vast amount of fibers and fabrics. Hence, the cost factor becomes important for the dye to be economically viable. Hence, the dye should be prepared from cheaper raw materials using few steps, and the application of dye should be simple without need of high temperatures or pressures. Next is fastness properties. The ability of a substrate to retain color when exposed to various agents is called its fastness. There are 6 important properties. First is light fastness, second is washing fastness, third is perspiration fastness, fourth is heat fastness, fifth is rubbing fastness, and sixth is bleaching fastness. So, let us discuss one by one. First is light fastness. Well, students, when a dye or printed fabric is exposed to sunlight, some portion of light is absorbed by the dye molecule. The energy thus absorbed may bring about the self-destruction of the dye molecule in the presence of oxygen and moisture from air, and so the fabric undergoes permanent fading. This permanent fading of fabric is called phototropism. Second is washing fastness. Well, the dye must possess good washing fastness. Otherwise, when 2 or more fabrics are washed together, staining of one fabric with dyes stripped from the other fabrics will occur. Third is perspiration fastness. We know that since human perspiration can be acidic or alkaline, the dye must have stability towards acidic or basic conditions of sweat, which is called as fastness towards perspiration. Fourth is heat fastness. The dyes which are applied at higher temperatures, like reactive dyes or dyes which are used for ceramic painting, should have stability towards higher temperature, and the property is called as fastness towards heat. Fifth is Rubbing fastness. The dyes which are used for leather garments should have resistance towards rubbing so that fading of leather hand gloves or jackets will not occur. This characteristic property is called as rubbing fastness. And last, that is sixth one, is bleaching fastness. The printed fabric, when subjected to bleaching process, the dye should have good resistance towards action of bleaching agents like chlorine, and the property is called as bleaching fastness. So students, in our today's lecture, we have started with the topic of Introduction to Dyestuff Industry. In that, we have seen in the introduction part the importance of the color, the definition of the term dyes, the requirements of a good dye, and the fastness properties.